Right after a rainstorm, the clouds begin to part and sunlight returns. Then a bright bridge of color may appear across the sky. It can feel like magic, but every rainbow is a precise experiment made by sunlight, water, and your point of view. So what is happening inside all those raindrops? Let's follow one beam of light and find out. It all begins with sunlight. Sunlight looks white to our eyes, but white light is a mixture of every visible wavelength. We often name 7 bands: red, orange, yellow, green, blue, indigo, and violet. In reality, the colors blend into one continuous spectrum. They travel together until something separates them. A glass prism can reveal those hidden colors by changing the path of light. In the sky, millions of nearly spherical raindrops do a similar job. Each drop behaves like a tiny optical laboratory, part prism and part curved mirror. Sunlight enters one side, turns inside the water, and returns toward the observer. Let's zoom into a single drop and slow the journey down. Step 1 is refraction. When sunlight moves from air into water, it slows down because light travels differently in the denser material. The change in speed makes the beam bend at the surface of the drop. Different wavelengths bend by slightly different amounts, so the colors have already begun to spread, even though they still look close together. Step 2 is internal reflection. The bent light reaches the curved back wall of the raindrop. Some light leaves the drop, but the part that makes the primary rainbow reflects from the inside surface and bounces back, much like light from a mirror. The round shape points that returning beam toward the front of the drop again. Step 3 is dispersion. As the reflected light exits the front of the raindrop, it refracts and bends once more. Each wavelength changes direction by a slightly different amount. Red bends the least, while violet bends the most. The once white beam now fans out into a spectrum. Countless drops send different colors to your eyes, building the rainbow you see. Your position completes the picture. To see a primary rainbow, stand with the sun behind you and rain in front. Red light reaches your eye at about 42 degrees from the point opposite the sun, violet arrives at a slightly smaller angle. Millions of correctly placed drops create the band, and every observer sees a personal rainbow. Bonus fact: a rainbow is a full circle centered opposite the sun. The horizon hides its lower half, but from an airplane you can see the complete ring. A double rainbow appears when light reflects twice inside each drop, reversing the color order. Look for this science after rain.